Okay, we're off. So a little bit about Workshop Wednesdays for those new joiners. Firstly, everyone is welcome, and that is the most important thing. If for some reason you don't feel welcome, then come and let me know, or let any of the moderators know. We do have a code of conduct at the bottom there if you feel like trudging your way through it. But the most important thing is everybody is welcome. If you get stuck, press raise a hand or type a question in the comments. And if you're the sort of person who knows the answer, please do help out. That's the point. We're a community. Share your LinkedIn, X, if we want to call it X, Twitter contact details, if you like. And let's see if we can make the world a little bit of a better place for Android developers by grouping together. A little bit on the next event. So the next one is on in 2 weeks' time. We're trying to do these every 2 weeks. So 31st of July, Naymat is going to talk about testing in Android. That's the number 4. Then we're going to have a break for summer over August, and we will be back in September. I don't have a specific date in September, but probably the 1st or 2nd Wednesday there. Finally, thank you to our sponsor, Apptaura, the app development experts based in the south of England. They employ me, so that's another good thing in their favour. But thank you very much to them for their sponsorship of this event. It means a lot. So on to our subject of the day, which is infinite conveyor belts, Kotlin Flows in Android, the number 3 session of our fledgling community. If you enjoy the session, then please do feel free to share it, share the knowledge of Workshop Wednesdays. I'm only me, I can't get it out as far as I would like to, but do please share on social media if you think if you find this worthwhile. A little bit about me. So I am CTO of Apptaura. Like I say, Apptaura are the ones that that employ me. I'm also a Google developer expert in Android, and my LinkedIn details are just there, TD Colvin. Also TD Colvin on Twitter, but I don't really, to be honest, do much there. So let's switch over to the reason we're all here. There we go. Flows, the infinite conveyor belt. Perfect. So this is what we're going to be talking about today. We have an hour. We are going to be talking about functions versus suspended functions. Obviously, if you were here 2 weeks ago, then you'll know that we were talking about coroutines and the suspend keyword came up quite a lot, and the difference between a function and a suspend function. But also we're going to talk about flows in that context as well. We're going to talk about flow operators, and then we'll have a hands-on to do with flow creation and operators. So just putting into practice those last couple of things. So those things are sort of fairly basic stuff. I appreciate that a number of you are probably aware of that already, but I do think it helps to sort of build up from the from ground zero, as it were, because there's so much sort of rote learning in Android, and we kind of need to unlearn that. We kind of need to understand why we got to the point we rote learned the stuff that we did. So I do think it's important to start from the very basics. So we weren't going to spend a lot of time on that. Then we're going to talk about Compose particularly, and how we can safely collect flows in Compose. We'll have a hands-on that as well. We will then talk about hot versus cold flows and turning cold flows hot and why we want to do that. We'll have a hands-on that. And finally, using state flows to encapsulate UI state. So the way that we can encapsulate state in view models and share that to the UI code. Again, the repository, if you didn't get it at the top of the call, if you've just joined us, that's at the bottom there. So you will need that before we get to the first hands-on. I will keep it as a link at the bottom there. So to kick off, let's talk about functions and flows. So a function in Kotlin is very, very straightforward. It takes an input and it gives you an output. And maybe the input or the output is nothing, but still it runs with an input and it gives you an output. A suspend function that we looked at a couple of weeks ago, well, that takes an input and that gives you an output after some time. So it's allowed to, say, go to a server and do a little bit of work, or just pause and wait around for something to happen on disk or something like that. But a suspend function gives you an output after a while. Only one output. A flow, and this is the important thing, a flow is the only thing that gives you multiple outputs. You could see it as a function that gives multiple outputs over time. So the way I teach it when I'm in front of a class is a Kotlin flow is like a conveyor belt of data. And obviously, if you've used other languages and other types of flows, RxJS springs to mind, or RxJava, or Combine in Swift, for example. But they're all very, very similar. It's a conveyor belt of data. There is something loading data, loading objects onto one end of the belt, and you that is calling that, executing that conveyor belt of data, you're the something else at the other end that's handling each object that's being put onto the belt. So how does that look from a point of view of code? Well, here's a conveyor belt. We have a conveyor belt. We're using here the operator, the function flow, to create our flow. And it's emitting numbers onto this conveyor belt. It's emitting numbers in a particular order with particular delays. And there's another thing at the other end that is collecting those numbers. So a couple of terms to define there. We say that the flow is emitting those numbers. It is an emitter. And we say that the thing that is collecting them is a collector. And that's the language that we use within Kotlin, which might be a little bit different to other similar things. But basically, you can sort of see how these things might become useful, how a flow might become useful in time. So that delay, for example, that you see in the flow that we've created there, that delay might be going off to a server and getting something, or it might be reading something from disk and then returning it. It might be waiting around for some timing, something to change. But basically, we're emitting things and there might be a delay and we might be emitting some more things. Some flows emit nothing. Some flows emit only one thing and then terminate. This terminates after 5. So a flow has a particular lifetime after which it terminates. It could go on forever. And that might be its life cycle. It might last forever. But basically, it sits in a box, and then the collection will stop. This collection over here will stop when the flow terminates. Okay, we can make this more complicated because we can bolt operators onto the end of flows, and that makes them quite powerful. So here's an operator that operates, for example, on each of those greeny boxes that are appearing on the flow there. It's an operator that is converting each of them into orange boxes. So conceptually, you can see how that works. Operators don't necessarily work on each individual element one by one. They might work on the flow as a whole. So you might find an operator returns just one or no elements, or returns, in fact, more elements, or emits, I should say, emits more elements than the flow that it's input into. But basically, we have an operator, the idea of the concept of an operator, and we can bolt multiple operators together. There are a huge amount of operators. Brace yourself for the next slide. This is not all of them. This is some of the operators that we get in Kotlin. I've highlighted in orange the two that are the most commonly used. Filter, which drops emissions that don't match a certain condition. So it's like filtering out data. A map, which applies a transformation function to each item in that original flow. Filter and map. The ones in blue are more commonly used. Basically, if you go to that web page, or go to the Kotlin documentation, perhaps just Google Kotlin flow operators. That's where that QR code takes you to. But there are huge numbers of them, and they all do useful things. They're all for bolting onto the end of a flow. So that's all relatively simple stuff, I hope. But let's just consolidate that with a hands-on to begin with. So hopefully you've got the repository. I'm not going to leave a lot of time to do these things, because I think this is all relatively low level, relatively basic. But if you have a look at the flow creation screen file within the project, you can create a flow that the app will show when you tap collect. So there's two parts to that. In fact, there is creating a flow, and there is the code that runs when you tap collect. And then we will move on to the second one. So if I share the project, so the first task is to write the code that collects your flow here in flow creation screen.kt, and write the actual flow to collect just down here. So I'll give you maybe just 1 minute to do that. And then we'll move on to the next thing. Again, I don't want to take too long over this basic stuff, but just for people who haven't met it before, or people who, it's kind of handy for starting again, so you're not rote learning these things. Obviously, put your hand up or write a question if there's any issues here, but give us a thumbs up when you're done. All right, one finished already. Well done, Chris. So hopefully your code will look something like this. And on collecting it, we've got this variable here called flow emissions that we can add to, and that's going to make it appear on the UI. So we can just do flow emissions plus equals it plus \n. Oh, where have we got a problem there? Flow. Oh, it's returning an int. And then if we run that and press start collecting, we see the numbers 1 and 2 appear. So we have created a flow and we've collected a flow. Simple stuff. The next task is to use a flow operator. So if we use this party guests flow, if you look at the bottom of the script, we've defined a whole load of party guests, one for each letter of the alphabet. And the task here is to firstly filter out people who are under the age of 18. They're not allowed in the party, so we've got to filter them out. And secondly, we're building party favors and we want the first letter of each person's name. That's all we want. So filter out the people who are under 18 and return for each emission only the first initial of their name. Again, I'll give you just a couple of minutes to do that. Give us a thumbs up when you are done, and then I'll go through it again. That was quick. Nice work. Okay. So it's a simple answer, really. So if we say party guest flow.collect, and we run that just as it is, well, we're going to collect all of the party guests exactly as they are. And they all arrive at 200 millisecond intervals. But like we say, we want to filter out anyone who's under 18. So for that, we're going to use filter. It.age is greater than or equal to 18. So now we're only getting the 18-year-olds. And we also want to grab just the first initial of their name. So we can use map for that. Map is the thing that transforms one thing into another. So we will map to it.name dot substring 0,1. And now if we run that same app, we should get just the first initials of all of those people who are over 18. As you can see, it's missing out D there, because D, whoever D was, is under 18. Anybody else get a different solution to that? Hey, nice. Yes, name dot first, so you can use dot first to get the first character of a string. Cool. Okay. Relatively easy, I hope. Let me know if there's any queries. Filter not age less than 18 is cool. Yes. Yeah, filter not is the opposite to filter. Hopefully, obviously. Right. Let's move on then. On to something a little bit more difficult. So that was the first hands-on. Okay. So let's talk about the right way to collect a flow in Compose. So we need to be cognizant of life cycle. We always have to be cognizant of life cycle. That was a theme in a couple of weeks ago when we talked about coroutines. Flows have the same kind of requirements. We need to make sure, in particular, that we are not collecting a flow for longer than we need, and there's certainly a danger that you could collect a flow that is ready for the UI, that is supposed to be displayed on the UI, in a way that after the UI is gone, you're still collecting it and you're still using resources. And to prevent that, we have this excellent function called collect as state with lifecycle. That comes from the lifecycle. You have to add the lifecycle pulling into your Gradle files, and that gives you collect as state with lifecycle, and that gives you a state for a particular flow. So once you've got a state, you can use the by keyword to get the actual value of it. So putting all that together, you have to get the latest headline, latest news headline from a headline flow. We can say latest news headline by latest headline flow dot collector's state with lifecycle. Now, one of the problems here is that latest headline flow might not return anything straight away. Lots of flows, in fact, don't return anything straight away. So what we want to do, what we have to do in order to make sure that this value actually has a value, is to tell collector's state with lifecycle what its initial value is. So latest headline flow is a flow of string. Latest news headline is a string itself, and we tell it the value that news headline is supposed to be before the flow has emitted anything. Which brings us to a second hands-on. So let's start with, in main activity, just comment out line 22 and uncomment line 25. So you should find in main activity that uncomments a thing called single clock screen. And there's two parts to this task. We want to convert the view model. So in this example, we have a view model in place. We have a flow called server time that outputs a readable date and time. We want to convert, it outputs a date. We want to convert it to a readable date and time. Then we want to collect the flow safely in the UI and display the result. So the answer is, of course, going to be collect as state with lifecycle, something that is collecting that flow only for as long as the composable that it's sat in is on the screen. So again, just a couple of minutes to do this one, and then I will go over it. Give us a thumbs up when you're done. Oh, you know what? I think the answer is already in there, unless I'm looking at the wrong thing. Oh no, I'm looking at the wrong thing. Okay, we have a thumbs up. Okay, here's my solution to it. So first we're going to uncomment single clock screen. And go to single clock screen just here. So this is a super inefficient clock that is basically going back to a server every 1 second to find what the latest time is. Yeah, the map is already in place. So we're mapping that date to a date format instance. And then the date string, just here, let's hide this. The date string that we want to display in the UI, we're going to get that not with equals, but by viewModel.serverTime.collectAsState with lifecycle, and give it an initial value of nothing. So basically, it's not going to display anything until the server comes back to us. There we go. Anyone else get that? Anyone else not get that? Any problems, issues? Okay, wonderful. So collector's state with lifecycle, to summarize, that is collecting this this flow for as long as this composable sits on the screen. And it's important to respect the lifecycle. That is the safe way to be collecting flows within Compose. Simple. So on to the next thing. We now need to talk about hot and cold flows. This is a bit of a weightier subject. So in the first task, you might have noticed that if you tapped the collect flow multiple times, even whilst the flow was currently running, it's going to start again and it's going to collect everything right from the beginning. You know, it's running that function that's returning multiple things as a flow is. It's going to run that from the beginning each time you collect. So every time you collect this cold flow, it's starting that conveyor belt again. It's creating a new conveyor belt. It's putting the same data onto it, and you're collecting that same data. That is what was called cold flow behavior. A hot flow is different. A hot flow exists regardless of what is collecting it. So these three things may be collecting this one particular hot flow, but the hot flow doesn't particularly care how many things are collecting. It's going to output the same thing regardless. There's a slight change of terminology as a result for a hot flow. Instead of collectors, even though the method is still called collect, instead of collectors, we call them subscribers. And you can sort of see that maybe a subscriber is something that, you know, starts at a particular point in time, even though it's been going on for you know, prior to now, as opposed to a collector, which kind of drives the flow. So if we give an example of a hot flow and some collectors, well, let's say there's a hot flow like this that's outputting 1, 2, 3, 4, 5 across time, like that, with gaps in time. And a first collector starts here and ends here. Well, it's going to pick up the 1, 2, 3, 4, and it's going to end. It's going to pick them up as and when the hot flow sends them out, and it's going to finish at that point. So it's not going to collect the 5. If we bring a second collector in that starts a little bit later, well, that second collector is naturally going to only pick up the 3. It's not going to pick up the 1 and the 2, because there's nothing in a hot flow generally that would say it's got a particular value or it starts with those numbers. I'd say generally there are specific kinds of hot flow which we'll get to, which are a bit different to that, but the general hot flow does not have the concept of a current value. So if collector 2 comes in at this point in time, it's going to be waiting for the first emission, which is number 3. Okay. Let's say there's a third collector that comes in at this point. So obviously it's going to find nothing before the 5, but that third collector, the hot flow terminates at this point. So collector 3 is going to naturally terminate at this point. You can't carry on collecting stuff after it's terminated. So collectors only collect what they're present for. And by default, there isn't a concept of a current value to a hot flow. Which brings us to, well, how can we turn a cold flow into a hot flow? Well, the answer is with the word sharing. So a cold flow shared is a hot flow. So what this sharing operator does here is internally, it's actually collecting everything from the cold flow, and then it's sort of broadcasting it to all of the collectors that might come in or out at any point in time. They might come in later or earlier, whatever. It's going to broadcast it to those. It's going to broadcast everything that it itself is receiving to all the collectors that are there at that particular point in time. The sharing operator works like this. It has 3 parameters to it. It has a scope, which tells you how long it exists. It has a started, which tells you when it begins collecting, and it has a replay, which tells you how many items of that cold flow get replayed to something that is just connected. So the scope is a coroutine scope. We saw that a couple of weeks ago, which basically, coroutine scope, if you remember, is like a box that you put a coroutine into, which limits its lifetime. Likewise, sharing has a coroutine scope that limits how long we're subscribing to that cold flow for. Started tells you whether we want to start right away and carry on collecting until for as long as that scope's alive. That's if we put sharing started.eagerly. Or we could only start collecting from the cold flow when the very first subscription to the hot flow comes in. That's lazily. Or there's other, you can actually you can create your own implementation of sharing started to do whatever behavior you like. So while subscribed is an example of an implementation of sharing started. So while subscribed will start at the point that the first subscriber comes in, and end at the point that the last subscriber leaves, plus a few seconds. You can give it a few seconds interval to just sit and wait, just in case something else comes in. And replay, how many items to replay to new subscribers. So basically, if you come in when the third emission is there and you've got a replay of 2, well, it's going to give you 1 and 2. And then 3 when it comes in. So it gives you a history of what has happened previously in this cold flow. Okay, that brings us to our last hands-on, which is perhaps a little bit more complex to know. So the idea here is to stop hammering the server. Let me demonstrate. So if we go to our flows workshop again, and in main activity, we uncomment single clock screen and go to multi-clock screen. and run this. Okay, so what I've done is I've created a clock that is split into different elements. So rather than putting it all on one line, we've got year, month, day, hour, minute, second, completely separately. And the way that that works is that year, month, day, hour, minute, second are all subscribed to the same, all subscribed to different elements of the view model, which, if we look at the view model itself, is each of which is just a map of the server time. So the problem here is if we look at the logcat, we'll find that it's going back to the server multiple times. So for every second it's going back to the server, it's actually hitting the server 6 times. So the problem there is that each of these is starting this server time afresh. So we're actually doing 6 times the amount of work in terms of networking, in terms of server costs that that we need to. So the challenge here is, what can we do to this server time cold flow to solve that problem? Again, I'll give you a couple of minutes. Raise hand if there's any issues, or give me a thumbs up if you've solved it. Let us know how you did so. All right, we have a thumbs up. All right, so here's my solution to it. The problem that we've got is that each of these server time maps, each of these flows, is restarting the server. It's grabbing a new instance of the server time. It's running that flow function in inverted commas all over again. So it's a cold flow. Server time is a cold flow. It should be a hot flow, because that will prevent it starting again each time. And to turn that cold flow into a hot flow, well, we just use share in, and we give it the view model scope, because that's the lifetime bounding box that we want to put this in. The view model scope, and we give it a sharing started. Sharing started. Lazily is pretty good. That will only start when the first subscriber comes in. That's kind of handy. Also, what's quite good within a view model is to use while subscribed and give it a stop timeout of like 5 seconds. The reason for that is because of the intricacies of the way Android works. You probably know that if say the screen gets rotated, or there's some change in parameters to the screen itself. The whole activity is torn down and brought back up again. The view model sticks around, but the activity doesn't. So if we use while subscribed with a timeout of 500, it prevents this flow from collapsing whilst the activity is reconfiguring itself and there's nothing on the screen. So 5,000, 5 seconds is probably a little bit conservative there. You're probably fine with 1 or 2 seconds. But basically you want to keep that flow going, that cold flow going during those configuration changes. Otherwise, when the configuration change comes back, when we come back from that configuration change, we're going to have to do all of that connecting to the server all over again. It's a bit of a weighty task. So sharing started while subscribed 5,000 gives you a 5,000 millisecond buffer where after the last subscriber disappears, the flow doesn't, the share doesn't stop collecting from that flow until that 5 seconds is over. So rotate screen, don't disconnect from server. So with that in place, let's have a look at our logcat and make sure that that has solved the problem. And it has. It's only going back to the server once a second now because this is a hot flow, not a cold flow now. All right, we're getting to the end now. There is only a few more things that I want to show you. Back to the slides. Okay. I wanted to talk about state flows. State flows are important. State flow is a hot flow which does have the concept of a current value. And an example state flow is a mutable state flow. That is one that is used a lot in the passing UI data from view model to UI. So if you have a look in your code, there's no particular hands-on task here, but just to show you the recommended way, it's a little bit of architecture stuff, show you the recommended way for grabbing UI data from a view model. Let's have a look at UI state flow screen. Okay. So if we just run this app to start with, let's go back to the main activity. I'll show you what the app does, and then we'll talk about how it achieves it. It's relatively straightforward, but it is really, really important, this stuff, in terms of the architecture of Android apps. There's only a few ways you can architect the data flow from view model to UI code, and this is one of them. So we have a changeable number, 1, 2, or 42, and a changeable color, red, green, blue. That's all that the app does. So the state of the UI only has 2 parameters to it. There's 2 things to the state of the UI here. And if we go to UI state flow screen.kt, this is the data class that describes the UI state. There is a color and a number. That's it. We have a view model which has a mutable state flow. Well, actually, let's go to this one first. We have a view model which has a UI state, which is a state flow of this my UI state. And if we look at the UI code, I'm going to scroll up to the UI code. What's happening is that the UI state is being grabbed in the way that we said was safe. So collector state with lifecycle from the viewModel.ui state. And this UI state then is being used with the text that has a color of color and the text of that number. Now, the buttons which set the color update this state flow. So we have a mutable state flow, that is a state flow that we can change. And the best way of updating this mutable state flow is using the .update function. The .update function gives you the previous state of the UI, and you're supposed to return the new state of the UI given that previous state. So it's a safe way of performing those updates. So we have UI state.update, and a good way of copying taking one copy of this data class from one thing to another is doing it.copy. So that is a copy of the previous UI state, my UI state class, setting the color to something else. So this is something that you should see all throughout your viewModel code every time we're updating the UI state. UI state.update, it.copy, and set one thing or change one or a couple of things within the UI state, which then triggers this code here. The UI state changes up here, and we can use the UI state throughout our UI building. So that was a mutable state flow. It's exposed to the UI as a state flow so that the UI can't make changes to it. And we update it using state.update, it.copy. Is everything clear? Any questions on that? I'll take that as a no. That's good. All right. So nothing left to do other than let's look at a brief summary of what we've done. So we have looked at what flows are. A flow is like a function that can return multiple values over time. And with a flow, you can transform the output of flows using operators. We showed a big long list of operators, but the most common ones are map and filter. And there are others that you use quite a lot as well. To safely collect flows from compose code, use collector's state with lifecycle. That is safe because it stops collecting. You can be certain that it stops collecting when your composable goes off the screen. We looked at cold and hot flows. Cold flows start afresh each time you collect from them, and hot flows kind of exist already, regardless of what's collecting them. We use share-in to convert a cold flow to a hot flow. And with share-in, a useful way of doing it is sharing started while subscribed to make sure that you're continuing to collect from the cold flow across the boundaries of those configuration changes within Android. So share-in converts a cold flow to a hot flow. A state flow is a hot flow which has the concept of a current value, and use state flow, specifically mutable state flow, to encapsulate the UI state in viewModels. That's it. Any questions? Yeah, go ahead.
Hey, Tom. Thanks a lot for the session. I got to understand more about Kotlin Flows. So I'm a bit new to Kotlin Flows because I'm coming off I'm trying to learn Jetpack Compose at the moment, so I'm coming up with knowledge of XML, live data and all that. And I would love you to explain a bit more the difference between flows and live data, kind of comparing between them, and also why flows replaced live data, because I still don't get it quite much. Thank you.
Yeah, so why did flows replace live data? How do they differ? One of the things that we get that is important here is that flows come from Kotlin. They're not Android specific. Live data was an Android thing. Flows are a Kotlin thing, and they work nicely with coroutines. They work nicely with the concept of scopes, and they're built into Compose. So you could say that flows are just a bit more modern version of live data. They do a little bit more. It's easier to operate on flows than it was on live data, as I recall. But the most important thing is that flows form part of Kotlin itself. So it's not a library that you bring in. It's not an Android specific thing that you're having to write. Flows come from Kotlin. And I suspect that that's what caused the Android team to move across to supporting flows more than live data. Concept-wise, they're very similar. They're very similar. Live data had hot flows and cold flows. Live data had a map and a transform and had less to do, but it had those things, and it was also it worked nicely from an XML and a data binding perspective, if I could recall correctly. It's been a little while since I've used live data, to be frank, but it did work nicely with binding. Yes. So Cassio says you can use state flows to state management on KMP, sharing code between platforms, but you can't do that with live data. Is that right? Yeah, live KMP. The best part of KMP at the moment is Compose multi-platform and doesn't really support live data. And I don't think that the live data library supports Kotlin multi-platform anyway. It's something that is essentially being discarded, not being used anymore. So I wouldn't have thought, willing to be told I'm wrong on this point, but I wouldn't have thought that works with Kotlin multi-platform at all. Does that answer the question? Awesome, cool. Any further questions? No, fine, okay. So yeah, just to remind then that the next event will be on the 31st of July with Matt, who's going to talk about testing in Android, which is a massive, great subject. So to make sure you come in and watch on that one, it's going to be an interesting one. I'm going to watch with bated breath. Otherwise, yeah, have a very good time. If you have any further questions, come and find me on LinkedIn, or yeah, find anybody else in the group as well. All right, take care all. Thank you very much indeed for coming along. Bye-bye.
Bye-bye, guys.